Hello world. Today I'm going to show you everything you need to know to make a working model of the solar system in a web page using the Three.js JavaScript library. This tutorial will include creating the sun, a planet orbiting the sun, a moon orbiting the planet, and a ring around the planet. This simple model is intended to serve as a starting point for you to expand in order to create your own solar system. There is a lot of material to cover, but I have tried to boil it down to its essentials. If you are coding along with the video, be prepared to push the pause button from time to time. Otherwise, download the source code from my website. You can get the Three.js JavaScript library from Three.js.org. For a project, there are certain files that we're just going to have in order to make things work. If you don't have all these files, your project is going to break. In the CubeMap directory, we have 6 image files. These images will be strung together in such a way that they will act as the walls for our scene. In the IMG directory, we have a map of the Earth, a map of the Moon, and also an image for the glowing corona of the Sun. In the JS directory, we have 3 library files that we're going to reference. .gui to provide a simple on-screen graphic user interface for the controls that we're going to pass to it. We've got the Orbit Controls JavaScript library, which will allow us to rotate around the scene with the camera, and the main Three.js JavaScript library, which will control the rendering and our animation. There will only be 2 files that we're going to be editing, index.html and main.js. The code inside the index.html file is really simple. Inside of our body, we're going to have a div tag with an ID of WebGL. This div tag is going to contain the entire scene that's going to be rendered by Three.js. And then we'll have several script tags here referencing our libraries and the main.js file that we're going to edit. In the main.js file, declare these variables here that we're going to instantiate inside of our initializing function. Then create another variable called planet segments, give it a value of 48. Then create an Earth data and a Moon data variable that are going to be defined from what's passed back from the construct planet data function. Don't worry, we're going to define this function soon. Then declare your orbit data variable, which is just going to be a JavaScript object with a numeric value and 2 Boolean values. This is going to control the speed of the planet's rotation and their orbit, and then define a clock variable using the 3.clock method. Next, define our construct planet data function. This function just returns a JavaScript object, and we have it here just to eliminate the redundancy of having to type the property names for a planet object for every single planet that you're going to define. Then create a function called getRing. This function will create a visible ring and add it to the scene. The important parts you need to know. First, we're going to create a ring geometry. Then we're going to define the material for the ring. And then we're going to mesh them together in an object. And we'll also need to rotate this on its x-axis. Otherwise, the ring is going to appear up and down. We want the ring to go horizontally, like around the equator of the planet. Next, define the getTube function. This one is very similar to the getRing function that we just defined. The main difference is this one uses the torus geometry to make a 3D ring. The rings created by this function are visually more appealing, but they take more processing time to render than the regular rings. So typically only use this for like the outer ring of Saturn or something of that nature. Then we define a function to create simple material skins for our planets. There's just going to be 2 options that we're going to be passing to these materials, the color and the map, both of which are passed to the function. Based on whatever string we pass for the type, it's going to return a different type of material. And create a function called createVisibleOrbits. All this is going to do is draw all of the orbits to be shown in the scene. Here we're only going to have one orbit, the one for the Earth. But if you construct your own solar system with more planets, this is where you would put the orbits for those planets. Then define a function to create spheres. Next, define a function called loadTexturePlanet. This one's going to create a planet and add it to your scene. Pass it the planet data, X, Y, and Z coordinates, and the material type. If the planet data has the texture defined, we're going to instantiate the passThis texture variable with whatever image is passed in the data. And then we've got to define our material. Notice we're using the getMaterial function that we defined earlier, just to simplify the process. And then define your planet by retrieving a sphere with a getSphere function. And then add the planet to your scene. Then afterwards set its position with the X, Y, and Z coordinates. Now define a function called getPointLight. This is just another function to simplify creating a light that disperses in all directions. Now we need to define a function that's going to move our planet in our animation. Because we're going to have controls to turn on and off the movement of our planets, we need to have this if statement here. If run rotation is set to true, and we don't have a value defined for stop rotation, then rotate the planet on its y-axis. And if we're running the planet on its orbit, then we need to change the planet's x and z positions. Here we're using the cosine and sine functions to return a value between 0 and 1. That is multiplied by the distance from the rotation axis, which is usually around the sun, in effect telling it how far from the sun it needs to be while it's rotating. Next, define a function to move moons around a planet. Essentially, it's going to run very similarly to the move planet function, which is why we're calling the move planet function here on line 211. However, we don't want to rotate the moon around the sun, we want it to rotate around its planet. Therefore, here on lines 213 and 214, that's why we're adding the x and z positions of the parent planet of the moon to the position of the moon. This is key to getting the moon to rotate around the planet itself. Next, we'll define a function called update. This function will be called in a loop in order to create our animation. Make sure that our point light is at the same position as our sun. Update the controls to move the camera wherever the user defines it to be. Instantiate a time variable with the current time. Then you'll need to move the Earth, the ring around the Earth, and the moon. After that, render your scene, call Three.js's request animation frame function, and inside the anonymous function that's passed to that request animation frame, recursively call the update function. Now for the last function to be defined, it's going to be called init. This is the function that starts everything. Start by creating the camera object. Next, define the position for your camera, and then tell your camera to look at the center of the scene. Now create the scene that holds all of your visible objects, and then create the renderer that controls your animation. Attach the renderer to the div element on your HTML page, and then create the controls that allows the user to move the scene with a mouse. And next, you'll need to load the images that are used in the background. These are going to be from your cube map directory that I showed you earlier. Then we're going to define a reflection cube, which is going to act as the walls to your scene, and attach the background cube to the scene. Next, create light from the sun, which is going to be the point light, using your getPointLight function, and add it to the scene. And next, if you want to be able to see the back of your planets, you're going to need to create some ambient light. So do so here and add it to your scene. And now we create the sun. We get some basic material because we don't need to have the surface of the sun being reflective. We're not going to have any images wrapped around the sun. It'll just be a big white glowing sphere. Now, in order to create the corona of the sun, we're going to create a sprite. Now, a sprite will always look the exact same no matter what angle you look at it. Set the scale of the sprite to be bigger than the sun, and then add the sprite to the sun itself. And this will center the glow around the sun. And now create the Earth, the moon, and a ring around the Earth using functions that we defined earlier. Call your create visible orbits function. And create the GUI that displays your controls using the .GUI library. We're going to add folders for light and speed. And then start the animation by calling the update function. And the absolute last thing you need to do to start everything is call the init function that we just ran through. And that's all there is to it. I hope this was helpful. Thank you for watching.